So today we'll be looking at the confusion matrix. We'll try to get an insight of it, and we'll run some tricks also to remember it. See, in classification, the data sets, we are classifying our data set into two classes, means different classes we have to classify. So data set can be of two types. It can be either balanced or imbalanced. A balanced data set or imbalance. The classes in the imbalanced dataset, they are called majority class and minority class. To understand this, consider an example of bank fraud case detection. Bank fraud transactions, fraud transactions. Say, in bank transactions, we have 98% of the transactions that are genuine cases, which are true cases, genuine transactions. Only 2% of the transactions, or else means similar to 2 to 5%, 10%, on very little cases, a small amount of cases, they will be the one that will be the fraud cases. For us, in our classification problem, in this situation, these 2%, which will be, these are important ones. These are the ones that we want to detect. The genuine transactions, these will be the majority class, and the fraudulent case will be the minority class. See, it is the minority class that are important, that make the news. For example, another example we can consider is of earthquake. See, we hear the news that today, that today there was no earthquake. We don't hear the news that there was no earthquake today. We hear the news that there was an earthquake. An earthquake is a rare case, rare event. So it is the minority cases. These are the ones that make the news, and thus these are the important ones. Thus these are the ones that we have to detect. Okay. So in classification, or any other model, one of the metric that is used to evaluate a model is accuracy. But this metric accuracy, it fails in imbalanced dataset. Why? Let's see with an example again. The bank fraud case. Consider a situation where we have 98% of genuine cases and 22% of fraud cases. Now if I have a model that is always classifying the transactions as genuine transactions. If I have any input that I am giving it, it is saying that it is a genuine, which means it's a lazy model, it's a useless model. But still in this case, it will be correct 98% of the times. 98% of the times it will be correct, only 2% of the times it will be wrong. So it will be having an accuracy of 98%. But we know that this model is not doing anything. It's a worthless, it's a useless model. Thus we get an idea that accuracy alone is not sufficient to evaluate a classification model. So to overcome this problem, we introduce two more metrics. These two metrics are precision and recall. There is one more metric other than that, which is called F1 score. And to evaluate this and to get an idea of the performance of the classification, we make a thing called confusion matrix. So confusion matrix is basically a table which can be used for the evaluation of our classification model and further compare it between two of them. Okay, so let's now look at the confusion matrix in detail. So how do we make a confusion matrix? It is a table. It's a 4 by 4 table like this. Here we will be writing the predicted values, and here I will be writing the actual values. Now the confusion matrix is best understood by an example, and since as we have studied before, there are two types, balanced and imbalanced type of data sets. First we will see how to do it on a balanced data set. After that we will see it on an imbalanced data set, and we will try to get a better understanding of it. So to understand it, first of all we will need a data set. Here I have created one data set for understanding purpose. Here male and female, these are the actual female male, which was the actual data set, and this was what was predicted by our machine learning algorithm. The machine that predicted it predicted female as male. This is the data set. This is for understanding here. In this example we will be using it. Let's come here. So in this, here we write true negative, and here we write true positive. Further, here we write false negative, and here we write false positive. Now the formula of okay, so we write here predicted, here actual, true negative, false positive, here it will be false negative, true positive. And with this we develop the formula of just a moment. Yeah, once we have this, we can write the formula of precision and recall. See, what is precision and recall? Precision says that out of the ones predicted as true, how many were actually corrected? Out of the ones predicted as true, how many were actually true? Or actually correct. And recall says that means half of the actual cases, out of the actual cases, how many were actually correct? So the formula for these two, precision and recall, we can get it from confusion matrix. If we take it this way, from here we get the formula of precision, and from here we'll get the formula of recall. So precision will be true positive upon false positive plus true positive, which means out of the ones predicted as true, which is predicted as positive, how many were actually true. Okay, and for recall we have formula true positive upon true positive plus false negative. Here we have true positive upon true positive plus false negative. Up till now I don't think you would have understood the things quite properly, but further as we move into two examples you will understand all these things. You have to bear with us for 5 to 10 minutes. So coming back to our example of first we'll see the example of male and female. To that example, let us talk about the prediction of males. Okay, so let's visit our example now. The example of prediction of male and female. As mentioned before, the data set is here. We will be utilizing this data set. Now, here is the matrix. And the class that I am interested in, that I wish to detect, is male, which will be my one class. So here I will write male. So I will write female here. Here I will write female. Here I will write male. So what is the figure that I want here? Here I want, and see, this is the actual values. These are the prediction values. So what I want is how many females were there who were actually predicted as females. So what value will I put here? We'll refer the data set. Let me copy this data set there. Just a minute. Okay. I can make it small, that's a good thing. And, okay. So how many females are there and how many of them have been predicted as females? So female and predicted as female, one case. There is only one case. I'll put here as 1. Now how many, here see, how many actually they were female and they were predicted as male. Here we are learning how to make the classification matrix, how to enter the values in the classification matrix. For the simplicity, we have chosen a basic example and it is a balanced dataset, not an imbalanced dataset. Further, we will be understanding the concept better in the imbalanced dataset also. So, female predicted as male. So, female predicted as male, that's the one case. Female predicted as male, second case. Female predicted as male, third case. So, here I have 3 cases here. Here I wish to add one more female predicted as male, just to make sure that you understand the example better. So this will be 4. Let us take it this way. Okay, coming now to this cell. Here actual value is male, but the model has predicted as female. How many those cases are there? So those cases will be MF. Let's just check it. MF, that's one case. That's the second case. That's the third case. So we have 3 cases here. They were actually male, but were predicted as female, and similarly here they were males and they were predicted as also male. So how many those cases are there? 1, 2, 3, okay, 3 cases only. So this is how we have filled the confusion matrix. Now let's have a look at it. Let us copy this